Hi, so this is a demo of massively parallel, massively scalable real-time compression and decompression of files as they're uploaded. So we're going to show uploading a large number of files. In this case, each file is 187.2 megabytes. That's about, when you get the actual number of bytes, it's, 187.2 times 1024 times 1024 puts it in the meg range. So that's about 196 uh, actual million bytes. And um, in terms of how many bits it is, that would be times 8, and that brings it up to about 1.5 billion bits. Our upload bandwidth is 28 megabit, 28 million bits. So we have each file is about 1.5 billion bits, trying to go over 28 million bits a second, and we have 10 of them, so that's the 15 billion uh, bits trying to go over about 30 million bits a second. And so there's compression going on too, so it's going to go faster than the 30 million bits per second. Let's choose 10. That brings it up to 1.87, around 1.87 gigabytes, almost 2 gigabytes. Let's see how long it takes. Buffering up front. And now they're going. That buffering is obviously because there's only one Node.js instance and it's limited in RAM. It's less than a gig of RAM for the instance. It's sitting behind Nginx, and on the same instance, the free tier AWS instance is T2 Micro with shared network bandwidth and very low power processor. Basically, it's free machine in the cloud, free instance in the cloud, not even a machine, and it's single virtual CPU that's equivalent to single core when it comes to threading. Multi-threading. So multi-threading is not happening. There's only one instance of Node. Just to show how this scales. Each one transfers in less than 18 seconds, but in total, so normally that would be like 3 minutes, right? Um, Times 10, 180 divided by 63, so that would be 3 minutes. But the funny thing is when you're transferring a whole bunch of them, actually goes faster. More of the network is utilized, more of Node is utilized. So this one is already done. That one is done. The other's catching up. I'll wait until all of them are done and take the worst and best. I think that this one was done first, which was uh, so just over 2 minutes. Yeah, this one is just under 2 minutes actually. So we gained a minute by having a lot of them go in parallel versus the maximum speed for one. So that's almost 2 gigabytes in 2 minutes. So it's a gigabyte a minute over 28 megabit. So over billion over billion bits going in over 28 million bits a second. And took about 2 minutes, 120 seconds. That was very fast. So the compression is giving us a lot of value. The parallelism is giving us a lot of value in terms of the web workers on the client, also in terms of nodes, I/O, event loop, that is ideal for I/O, and how the compression is negligible in terms of CPU bandwidth. Uh, you don't see a lot of blocking here. Um, so this is all great progress.